Eolian processes. In comparison with Mars, wind-produced landforms are rare on Earth. Why is this, when Earth has a much more substantial atmosphere than Mars? The answer ultimately centers around the lack of abundant water on the surface of Mars instead of its atmosphere. Surface processes dominated by water and ice operate at a much higher rate than do Eolian processes. On Earth, there is abundant liquid water and ice, but on Mars, there is little ice and essentially no liquid water on its surface. Consequently, on Mars, Eolian processes have little competition from other surface processes. Added to this, the wind-blown sediments on Earth and Mars are different. They generally have different average grain sizes and different compositions. On Earth, wind-blown materials are generally composed of sand-sized quartz grains that chemically weather out of silicon, aluminum-rich crustal rock. Quartz is a common mineral in rocks that form Earth's crust. It is particularly tough and resistant to weathering and abrasion, and it rarely wears down to dust size. But quartz is rare on Mars. Instead, wind-blown materials on Mars are generally composed of dust-sized grains of iron-rich clay. The grains are the weathering products of the abundant iron and magnesium-rich volcanic rocks commonly found on the Martian surface. These iron-rich minerals are particularly susceptible to weathering and abrasion on Mars. Though these materials typically weather out of the parent rock as large particles, they quickly pass through the sand sizes to become dust particles. And that is Eolian processes.